Have you ever wondered how price comparison sites check hundreds of stores in seconds? Or how some companies run thousands of tests on their websites before every release? Or how some services generate perfectly formatted PDFs from web pages on demand? Well, behind all of that are headless browsers. Browsers that run without a window, and you can control them entirely by code, doing the work that would take humans hours in just seconds. In this video, I'll show you what a headless browser is, how it works, and give you real examples you can run right now. So what actually is a headless browser? Well, a headless browser is a fully functional web browser that doesn't need a monitor. Think about everything your browser does when you visit a website. It fetches and parses HTML, executes JavaScript, it can store cookies, handle network requests, and it manages sessions. Well, a headless browser does all of that. The only thing it doesn't do, render pixels to a screen. Instead of clicking buttons and scrolling pages with a mouse, you control it through code. You write scripts that tell the browser exactly what to do. Go to this URL, click on that element, wait for this content to load, and then extract that data. Here's what running a headless browser looks like. This is the path where my Chrome binaries live. And if I run this one command, it basically launches the Chrome and tells it to fetch a web page and then dumps the entire HTML to the terminal. That's the core concept, a real browser running in the background, controlled entirely by code. You get the full browser engine without the visual layer, and that's what makes headless browsers so useful for automation. There are a lot of libraries out there that help control browsers. The most famous ones are Puppeteer and Playwright, which we'll go over in this video. Now that you know what a headless browser is, let's see how it compares to a regular browser. So here's the same Puppeteer script running side by side. The only difference is one flag. Headless set to true or set to false. On the left, we have headless set to false. That's called headful mode, the normal browser that you're used to. When we run it, Chrome opens up, navigates to the page, does its thing, and closes. And you can see everything happening in real time. Now, on the right side, we have headless mode. As you can see, the script does the exact same thing, but nothing opens on screen. The browser runs completely invisible, and we still get the same output in the terminal. So you might ask yourself, what's the difference in practice? Headless is faster because it skips rendering pixels. It uses less memory, less CPU, and runs easily on servers without a display. The trade-off is that headless browsers can be easier to detect as bots. Some websites check for things like missing plugins, rendering inconsistencies, phony user agent strings, or automation flags that headless mode exposes. So for most automation tasks like scraping, testing, generating PDFs and screenshot, headless is what you want. But when you're debugging or dealing with sites that have strict bot detection, switching to headful mode can definitely help. So what do developers actually use headless browsers for? Let's go through the most common use cases. First, AI integrations. LLMs can't browse the web. They can't click, wait for content, or interact with real pages. Headless browsers fix that. They let AI navigate sites, solve bot detection, CAPTCHAs, execute JavaScript, extract live data. This enables AI agents that can research, monitor, and interact with complex websites in real time. And instead of building all that logic yourself, tools like Browserless Smart Scraper with MCP let AI pull structured data from any site with a single call. Basically, headless browsers give AI eyes and hands on the web. Second, web scraping. A lot of websites today don't just serve static HTML. They load content dynamically with JavaScript, which means they make API calls after the page loads, and then they render the data on the client side. If you try to scrape these sites with a simple HTTP request, you get back an empty shell. The actual content isn't there. By design, it'll only load until the browser loads. Headless browsers solve this. They execute JavaScript just like a real browser would, wait for the content to load, and then you can extract exactly what you need. Third, automated testing. Headless browsers let you run end-to-end tests on your web application at scale. Login flows, form submissions, checkout processes, user journeys, you name it. You can run hundreds of tests in parallel inside your CI/CD pipeline. Catch bugs before they reach production, and do it all without a single browser window opening. Fourth, generating PDFs and screenshots. If you need to create invoices, reports, or preview images programmatically, then you can build the content in HTML and let the headless browser render it. And then you can export directly to PDF or PNG. Couple lines of code and you have pixel perfect images or PDF ready to share. And fifth, performance monitoring. Tools like Lighthouse can run in headless mode to audit your website automatically. You can measure load times, core web vitals, accessibility scores, the whole 9 yards. Instead of manually checking your site's performance, you automate it and get alerts when something's not going well. And you can catch problems before your users do. So these are the most common use cases, but headless browsers can handle almost anything a regular browser can do. If it involves interacting with the web page programmatically, you can bet a headless browser can do it too. So what tools are we actually using? Let's start with the browsers themselves. First, headless Chrome or Chromium are the industry standard. They're the most widely used, have the best documentation, and most automation tools are built around them. You can use a library like Puppeteer or Playwright to run this. Now, if you use Playwright, you'll unlock more browsers like Firefox, Edge, and WebKit. Headless Firefox is a solid alternative. It has strong privacy defaults and good standards compliance. Headless Edge is built on Chromium. It's great for testing real-world user scenarios, especially in enterprise environments where Edge is the default browser. And WebKit, which is Safari's engine, is really good if you need to test how your site behaves on Apple devices. All of these tools work really well. Which one you choose depends on your use case, your language preference, and whether you need cross-browser support. There are 2 ways to run headless browsers. First, you can run them locally. You'll install Chrome and Puppeteer on your machine, write your script, and run it. The browser spins up on your computer, does its job, and closes. This works fine for development, small tasks, and testing your automation logic, but you're managing everything yourself. So memory usage, crashes, zombie processes that don't close properly, and once you need to run multiple browsers at the same time, your local machine hits its limits fast. The second option is connecting to a browser running in the cloud. Instead of launching a browser locally, you connect to one that's already running on managed infrastructure. The browser runs remotely, you send commands over a WebSocket connection, and you get results back. Look at the code. 1 line changes. Puppeteer launch becomes Puppeteer Connect. That's it. And if you want to run it with headless false flag that we mentioned earlier in this video, just add this to the code and headless false, and you're done. It won't open up a browser on your machine because it's running on a remote machine in our cloud. But it'll come with the benefit that your browser fingerprint is immediately more human-like. Services like Browserless handle the scaling, crash recovery, and session management for you. You skip the local Chrome installation, the memory issues, and the infrastructure headaches. For production workloads or anything beyond a few concurrent sessions, this is usually the better path. Okay, so let's put this into practice with a real example. Here's a simple script. We connect to a headless Chrome instance, open a new page, navigate to Hacker News, grab the page title, and then close the browser. Let's run it. And that's it, Hacker News. Okay, so what if I want to capture a screenshot? Well, just add the line page.screenshot. Set it to full page, and then you can save it to a file. Now we have the entire page captured. This is exactly how services generate preview images, how monitoring tools captured page states, how developers debug rendering issues across different environments, and it's easy as that. That's headless browsers. Real browsers that run without a window and are controlled through code. Remember, you can use them to script dynamic content, run automated tests, generate PDFs, screenshots, monitor performance, and a lot more. If you just want to skip the infrastructure headaches and just connect to browsers that are ready to go, you want to check out Browserless. We handle the browsers so you can handle the automation. Links in the description. This was Alejandro from Browserless. Thank you for watching.